Okay, good morning, everyone. Today I'm going to talk about this paper. So please raise your hand if you read this paper. Read it. Okay, ever read it? Okay, good. So this is like one of the good mechanotherapeutic related paper. So they are using hydrogel dressing, integrating FAK inhibition, and ROS scavenging for mechano-chemical treatment of atopic dermatitis. So they are targeting to regenerate the atopic dermatitis. Okay. Well, let's see one by one. So this is their concept. So maybe you guys have some experience to have this kind of dermatitis on your skin, right? In that case, we normally just automatically use scratch it, right? So here they're focusing this scratching can induce more severe symptom of dermatitis. And then definitely when you scratch your skin, they are inducing some mechano-related something, right? So here they mentioned that when you scratch your skin induced by atopic dermatitis, and then they are enhancing intracellular calcium level, and then they activating FAK. And then when they activate FAK, they reduce cell-to-cell interaction. And then when they induce cell-to-cell interaction decreasing, this is one of the symptom of dermatitis, right? And then they are inducing more cytokine or chemokine, and then they are making more severe atopic dermatitis symptoms. Definitely, there's some illness of dermatitis, high level of ROS that can induce more inflammation. So, so originally, we already know that dermatitis can be increased by inflammation level, and then that can be induced by intracellular ROS level, right? So everybody knows that RS level should be decreased, compromised, but they didn't focus that much of the lower of the scratching, right? So here, already previously they mentioned that scratching can enhance FAK level, phosphorylation, and then they can induce more loss of cell-to-cell interaction. But so that is why they are targeting RS level as well as phospho FAK level. Okay. And then so they are making this special hydrogel. So even though they are mentioning about some antibacterial effect, but their major focus is decreasing RS level, right? And then what else? What else? Decreasing phosphoeffect level. Okay. So actually here, even though they mentioned about the intracellular calcium level, but they didn't specifically investigate the intracellular calcium level here. But we already know that force can induce increase of intracellular calcium level, and then that's why they are highlighting like this. Somehow they are inhibiting FAK phosphorylation, and then they can recover the cell-to-cell interaction. So structure preserving can happen, right? So all the story is that so they want to elevate the atopic dermatitis symptoms by decreasing oxidative stress and then decreasing phosphoeffect level. And then they can induce more inhibiting of inflammation and they can enhance rebuilding the skin barrier. Right? This whole their concept. So here, the major point is without this FAK phosphorylation targeting, they cannot publish this very good journal. Okay. Well, you think about this like 2 or 3 years ago. Here they submitted their paper November 2022, second, right? So now 2025. So you have to think about more. Okay. So what kind of thing you can deliver or you can target mechanosensitive some molecule, right? So this is their like figure. So I want you to draw this kind of figure in your paper, ongoing paper, or in your study, right? This is very important nowadays. Without this kind of graphical schematic images, people cannot easily understand your topic because they don't have enough time, right? So you clearly mention what is your hypothesis, and then when you draw this hypothesis, definitely you have to make it very beautiful like this. Okay, some specific color, and then their motion. So we already have our biorender ID. So you have to use that one a lot. And then there's this very easy story. They are increasing the impact of the study using human sample, human normal skin, human atopic dermatitis skin. That they measure the epidermis thickness and then phospho-FAK level. Okay, when you look at A, normal and AD, they have more epidermal thickness. This is very well-known symptom. They mimic this kind of condition by mouse, normal mouse, and then atopic dermatitis mouse, atopic dermatitis plus scratch. So you are questioning about how they make the scratch. So when they want to make this atopic dermatitis on the mouse skin, they are using special agent, this MC903. So this is very like unique agent. They are targeting Th2 mediated inflammation. So this is very uh, similar similar mechanism to induce atopic dermatitis in mouse model. And then you are questioning about why they're using mouse. Actually, it's in rat skin, mouse skin, they are quite different. Rat skin, they're contracting very fast, so their regeneration pattern is not similar to the human. So that's why people use a lot of mouse for mimicking human skin regeneration, something like that. Okay, but when you think about another like defect like muscle or bone, then sometimes red is more relevant. Or regardless red or mouse, you can use both of them. So depending on your targeting tissue, you can pick up rabbit, rat, or mouse. Everybody has their own region. Okay, and then they want to make some scratch. So it's not easy to make mimic the scratch. So when you look at this material method, how they induce the scratching is that they are using special tegaderm. Tegaderm is kind of like adhesive band on the skin, and then they apply this tegaderm on the skin, detach, and then they are making like 10 times a day, something like that, to induce this kind of scratch-induced dermatitis more. Okay, but so now in our eye trend, with the collaboration of medical doctor, we're trying to mimic this kind of condition as well. So if you need some interest, just let me know. Okay. So anyhow, they are mimicking this atopic dermatitis with scratch. So they found out this epidermal thickness is higher. Okay, higher here. And then they look at the phospho-FAK level. Phospho-FAK level, human AD has higher phospho-FAK level, and in mouse as well, compared to normal AD and AD scratch, they have more phospho-FAK level. So they confirm their hypothesis. Actually, this is a very well-known phenomenon, previously well-known. When atopic dermatitis happen, phospho-FAK increase. So they're making this kind of higher epidermal thickness. And then you think about that. Why they are making this higher thickness of epidermis? Because from the skin point of view, when phospho-FAK level is increased, they are making loss of cell-to-cell interaction. And then, but meanwhile, the skin, they have to maintain their uh, barrier, right? This skin barrier is very important to block such a kind of oxygen or bacteria or virus, something like that. So automatically, they are making more epidermis layer to prevent the inflammation from outside. Okay, so they're natural phenomena. So here they show us they are making successfully scratch-induced epidermal and atopic dermatitis model, right here. And now they want to make some special material to regenerate this kind of dermatitis. So they are making some special nanoparticle consisting of PDA, and then they also want to make liposome, and then they want to encapsulate FAK inhibitor in the liposome. Okay, so they check their diameter and zeta potential, like this 1 nanometer, something like that, and zeta potential also they are showing this kind of value -50 and more enhanced, and this nanoparticle as well. So they also show us schematic images how they make this material. Base material is hydrogel, And then they're making this PDA nanoparticle and then FAK inhibitor, including lipo-LA. And then their hydrogel is consists of this PBA and HADA construction. Okay, so they are adding this PDA and FAK inhibitor together. So you think about why they are adding this PDA and FAK inhibitor. FAK inhibitor definitely they want to reduce the FAK level, right? PDA is for reducing ROS level. So if you think about some special like material that can decrease ROS as well as decrease FAK level, and that's gonna be good. But here they didn't find that special one agent to decrease ROS level and FAK inhibitor. So that is why they are making two components together and they incorporate them in one hydrogel. Then they check their adhesion strength. This P definitely hydrogel including PDA. F is hydrogen including FAK inhibitor, PF, both of them. So there's certain change. When they're adding this PDA, they have more adhesion strength, their benefit. Not even they're decreasing RS level, they're also enhancing adhesion strength. And this, but the hydrogel itself, their stiffness is not much change, stretch modulus. Okay, and then here they show us this is called uh, self-healing ability. So they change the strength from 1% and it's 300%, and again change it. So 1% they maintain their high modulus, which means they sustain their physical property. When they increase their strength percentage using biology, and then they are decreasing a lot, but they are coming back, right? This is the exact meaning of self-healing. Self-healing is that, okay, when you scratch this hydrogel automatically, and then sometimes, oh, I can scratch, they are destroyed, but when you stop it, they are automatically healed together to maintain their physical property. So this is one of their concept why this material is quite good. But when you think about the most of the hydrogel, actually they have this kind of phenomenon, right? This is like beneficial benefit of the hydrogel. And now here you think about when you are making the hydrogel self-healing property, there's one thing you can show us. And then after applying this hydrogel in certain skin, when you band or torture or this is like exact meaning of self-healing. When you divide it and when you combine them together, and then they're making this kind of contact. So and then they're also scratchable. Then because of uh this hydrogen property, this actually when they want to make this CSCM and HADA, they already known that they have antibacterial effect. So they are highlighting antibacterial effect from the hydrogen itself. That they are quite multifunctional, right? Antibacterial, and then FAK inhibitor, and then ROS, and a little increase of adhesion strength. So when you're making certain material, you have to think about how you increase the number of the benefit like this. And then you will know how you can show us the benefit of the material. Now, because of the PDA nanoparticle concentration, you can induce ROS scavenging effect. So this ROS scavenging, another like HO and O2 minus level, they are decreasing. And then they want to show us cell salvage, cell increasing effect. H2O2, very high concentration, 10 millimole, they can decreasing the cell viability. And then when you add PDA level, they are enhanced. So this nanoparticle that can rescue the cell survivor. And then definitely they check the RS level. This loss, they are making more high RS level as a passive control. But when they incubate them with this polydopa PDA included hydrogel, they can decrease RS level. So they confirm it. RS level decrease and then survival enhance. And then you can think that this is very like smart approach. Here, they only using nanoparticle to show us the ROC effect, right? Here, they're only using ACP, right? They didn't show us other like hydrogel, HCF, HCP, especially HCPF, right? So actually, this is much better if we show us other group, HCF, HCPF. HCPF probably they have similar effect, but HCF they don't have PDA, so probably they didn't show us very strong anti-ROS level. But here they only show us HCP because we can easily expect it, right? So also you have to think about how you minimize your experimental setup. Well, actually, if I were review or about this paper, probably I should mention you have to show us HCF and HCPF as well. But when you think about the like as a first experiment to show this effect of the HCP, and then you can try HCP cell and PDA nanoparticle cell. They show the antibacterial effect, and then when they are incorporated in the hydrogel, they show us. And then next step, you confirm again using other HCF and HCPF. Okay, continue gradually you can show us. And now, so first they're targeting, they're from like cell study, they show us the ROS effect, anti-ROS effect. Now it's time to show us FAK inhibitor effect. Here also, they show us the single component, lipo-LA with FAK inhibitor. The PFAK level is decreasing as you expected, right? And then this FAK inhibitor, they can release quite well within 2 hours, almost like 20%. And then we can mention this like slow releasing. And then here, this is very interesting. They try to mimic this scratch mechanical force using stretching machine. This is like this very like elastic like PDMS material. They culture this epidermis cell, keratinocyte cell line. They are making two different compartment. And they are adding HCF, which has FAK inhibitor, HC, which doesn't have FAK inhibitor. And then at the same time, you stretch it. Maybe they stretch like 30% or 10%, something like that. Yeah. Here, they stretch it. They want to show us the effect of FAK inhibitor. And then this is very interesting. When they do without any stretching, they didn't show us very high level of ecadrin, very low. But when you induce 5%, it's like mimicking condition of uh, our real skin condition. They're making very high level of ecadrin. But when they stretch more, another stretch 30%, they are dramatically decrease. So 5% is like normal range of skin, like their natural condition. 30% is scratching induced, more harsh condition for them, right? In vivo and in vitro. So we can mimic this kind of normal skin tension and then scratching induced like mechanical force damage by the stretching, right? So and then this decreasing how much there could be enhanced by FAK inhibitor. You can see that the green color is more maintained in HCF, right? So this is like their quantification. Their deficiency very much deficiency very low, which means more ecadrin, and they are enhanced by HCF. They're more maintained. And then factor level of TNF alpha, this kind of like bad cytokine can induce, which can induce more severe damage of dermatitis. Oh, sorry, they're more decreasing under FAK inhibitor condition here, here, and here. Okay. So this is also a very smart way. They are minimizing. They didn't show us like HCPF, right? Here as a concept, they show us only HC and HCF. But sometimes it's enough because definitely when there's HCPF with PDA, definitely they show similar thing. But probably they want to minimize the experiment setup. Okay. But when the probably there are also many possibility the reviewer can ask. You have to confirm again after adding the PDA nanoparticle. But as a first trial, you can show like that. And then they applying their gel in this atopic dermatitis induced and then scratch induced model. So here it's like normal, add scratch. Definitely you can see more severe dermatitis. They apply HC, PF, PF together. And then here, it's like this very good schematic. How they induce dermatitis. They doing this scratch for 10 times. Then they're adding 45 micromole, this special agent, for 2 weeks. And then they are inducing like this. And then they apply hydrogel. And in the meantime, they apply again this component and scratch as well. Right. So here they mention every day they change the hydrogel. Sorry, not every day. When they do this scratch thing, they remove the hydrogel from the skin. Then they doing this scratching thing, and then apply the hydrogel again. Right. It's quite like labor intensive work, right? And then they confirm the epidermal score from the histological point of view and epidermal thickness, the number of the mast cell. Mast cell is one of the key cell to induce the dermatitis, atopic dermatitis, like inflammation, allergy reaction. So here they show us AD scratch this higher epidermal thickness quite decreasing when you apply the HCPF here, and then gradually the number of the mast cell number they are in charge of very severe allergy reaction. The number is decreasing quite a lot because of FAK inhibitor and then PD nanoparticle. So from here you can see that PD nanoparticle itself, H and then FAK inhibitor itself, they can reduce dermatitis score, and then you can see the synergy effect from PF. And then somebody can ask, what is the synergy in biology? 1 plus 1 equal 2 is synergy. But easily we can make, when we think about synergy effect is 1 plus 1 can over 2, maybe 3 or 4, they can be synergistic, right? But in biology, we didn't show like that. One effect, 1 plus 1 can be equal to, which means synergy effect from biology. It's not easy, yeah, always. And then not equal to 2. Actually 1 plus 1, and then they can be like 1.5. We can also say that synergetic, right? And this, when you combine these two effects together, that they are better than one single effect, and we can say synergetic in biology. So this is the meaning of synergetic. So we can see that most of them, they have synergetic effect. And then from the number of mast cell, this PDA, ROS scavenging is not enough to decrease the mast cell number, but FAK inhibitor, they are enough, right? So you here, and then like that, and then this epidermal thickness point of view, FAK inhibitor and PDA nanoparticle, they have similar effect. Similarly, but when they combine together, they are more decreasing. Then that is why we can say synergetic effect. And the last one, they confirm again using in vivo tissue, using this kind of cytokine from the skin, CCL, TSLP, Ig level, interleukin 4, certain level. Compared to normal group, this edge scratch they are enhanced a lot, and then depending on their condition, we can decreasing their level at a certain point. And then ecadrin level also they are quite lost, even though the thickness is quite higher than normal tissue. But when you look at detail about the ecadrin condition, most of them they are loss of ecadrin. So that's why they measure the tissue thickness with ecadrin deficiency. Even though this kind of higher like thickness, this area you can see the ecadrin, but this area you cannot see. So this is a loss of ecadrin. So they measure this loss of ecadrin. From the scratch AD, gradually they are decreasing, right? And then from the pelagen, for inter another marker for maintaining the skin barrier they are decreasing a lot, and then they're somehow they're enhanced. So here they can say that this hydrogel reduces inflammation from the ELISA, and then epidermal barrier damage, they also recover it from ecadrin deficiency level, as well as this flagging staining. Okay, this is the end of the story. So any question from this? You can, yes. Any question while we are reading this paper? Yes.
They they check for the FAK phosphorylation.
Mhm.
I want to ask if are there anything that could lead to a downstream process that might affect this process later?
Later. So you mean the downstream effect of the FAK? FAK. Let's think about that.
Because they are inhibiting important process in the cellular, and because of this inhibition, there might be a downstream effect later in the downstream.
Yeah, yeah, it could be true. So here they only mention about this when you inhibit FAK phosphorylation, they only show us like this FAK phosphorylation that can induce the loss of cell-to-cell interaction, which can be confirmed by the ecadrin level, right? But like you mentioned, also they can affect another like concept, right? What can be done when FAK phosphorylation is enhanced? Maybe uh, normally FAK phosphorylation is enhanced, cell migration can be enhanced, and then like epidermal mesenchyme transition also that can be also enhanced. So depending on the like context, many things can be enhanced or changed, right? But here they want to show us clearly the load of FAK to cell-to-cell interaction. You are right. This FAK when you touch the FAK, many things can be changed. FAK is quite core to regulate the cell behavior. But if you show like very another point of view, it's not easy to show us very clear images, a clear concept, right? So that's why even though there are a lot of like FAK latest phenomenon, they only show us this cell-to-cell interaction. Yeah, this is one of the smart way. But maybe probably we can ask, what is another effect of when you inhibit FAK? Is there any kind of other unexpected result from FAK phosphorylation inhibition? Probably that can be happen. But as a conceptually, you can show us when you stop FAK inhibitor, FAK phosphorylation, they recover the cell-to-cell interaction. It's quite important for maintaining skin barrier. This is my understanding. So here, take-home message is that you don't need to do all the experiments, and then you think about how you smartly show your rationale and try to minimize the experiment setup. But actually, sometimes it worked like this paper, but sometimes the reviewer probably they ask again, show us after you only show us like the nanoparticle effect, but please show us the effect of the hydrogel. And then when you incorporate PDA in hydrogel, it's okay. But what happened when you incorporate PDA and FAK inhibitor liposome together? They show us continuous like that, but you also think about how you simply show your data like this. Okay, thank you.